Hey, it's time for us to write a complete program from scratch. So we're going to do the classic interview question FizzBuzz. Don't ask me why it's an interview question, but it is. And let's do it in assembly language from start to finish. First, let's examine what the specification is. So we're going to count from 0 to n. Let's make n 100. And if the value is divisible by 3, print fizz. If the value is divisible by 5, print buzz. If the value is divisible by both 3 and 5, print FizzBuzz. Otherwise, print the number. Okay, so that's the specification. Let's add some boilerplate, which I know we're going to need. We need to expose main to the linker. I'm about to start entering code, and the code should certainly begin on an even address. Let's go ahead and add main, and we'll make this a complete program right from the start so that I'm always developing something that is runnable and testable. There, I've done actually a complete program. Here's the end of the source code. Sure, let me try it. So I'm going to save, give me a shell. That's the wrong operating system. Give me a shell. And let's see if it compiles. Let's see if it runs. It does. There, complete program. But we're not finished. So I know I'm going to need some strings. So I'm going to start entering data. I'm going to need fizz. That's a label, and here's the data that associates with it. It's a null terminated string, and that's going to have the value fizz. Notice I am choosing not to put a new line there, and that's because I want to accumulate the output of fizz and or buzz to produce, if appropriate, fizz buzz. Okay, so here comes buzz. .ASCII Z buzz, and here's my new line, .ASCII Z, new line, and I also need a template for printing the number if it's neither a multiple of 3 or nor 5. So let's do that. Here's the format for printf, and that's going to be print me a number and give me a new line. Okay, so I added that. Let's make sure I have not committed any errors. It still builds. Good. No reason to test because I haven't changed any of the code. Okay, so next piece of boilerplate but I'm going to change this. So I'll begin with a store of a single register x30 to the stack pointer, to the stack, pre-decrementing the stack by 16. Remember, you must always manipulate the stack in multiples of 16. Whether you're putting 1 byte on the stack, you got to move it by 16. If you're doing 17 bytes on the stack, you got to move it by 32. It's always a multiple of 16. Now let's undo that from the stack pointer with a, let's see, the first one is a pre-decrement. This one's going to be a post-increment, which exactly undoes the above. Also, I'll add in the return value of the program. Now, why is this a W register? It's because main is defined as an int. So a W register is an int 32. Okay, I've changed some code. Let's see if it builds. It does. Let's see if it runs. And let's see what the return code of the program is. It's a 0. Let me demonstrate how that return code gets made. So there's a 9. Build it, run it, and let's see the return code. There's your 9. So every program is started by another program. So in a sense, you can think of a program as a giant self-contained function which has to return a value to the program that called it. In this case, the program that is calling my program is this shell right here. So let's put that WZR, that's the 0 register for W values. Whenever you read from it, it is always a 0. And if you write to it, the write is ignored. All right. The next thing I want to do is start thinking about what my data, what values do I need to keep around in order to write this program? So I will often call that a dictionary. You might also call it your Bible. And let me start making some additions to it, and you'll see what I mean. I'm going to need a place to store the counter. I'm going to put that in X20. And I'm choosing X20 because it's greater than or equal to 19. 19 through 29 are persistent are registers which persist across system calls. However, X19 through 29 are registers. If I use them, I have to back them up and restore them the same way that I did X30. I told you that I was going to modify lines 18 and 19, and here you see why. So this is going to keep my counter. And let's see, what else do you think I'll need? I'm going to need a Boolean. So it could be W21, could be X21. So that's a Boolean that says whether or not I have printed anything. Now, what I'm going to do with that is I'll do my test against 3. I'll do my test against 5. Now, if I print something, I'll make this W21 true so that if I find it's false, I know I need to print the number. Let's see. This is all I can think of right now, but there might be more. So let me take care of what I'm using now. I'll change this to a store pair. That means that will be a load pair. And here, let me back up X20 and make sure I get them in the same order here. X20. Now, whoops, I have made a boo-boo. There. I did a Mac command shortcut, which was interpreted differently in Linux. Now I also need to back up W21, which is the same as X21. So I'll just say X21. Once again, now here's 8 bytes going on the stack, but I still have to manipulate it in units or multiples of 16. And I have to do the mirror image. Notice the order here. 20, 30, 21 going onto the stack. Therefore, coming off the stack, it's the reverse, 21, 20, and 30. Okay, so that will be from the stack with an increment, post increment. Let's see, so I've changed some code. Time to test. And see if it builds, and see if it runs, and see if it gives me the right output. Everything seems good. Okay. Next, we can implement the loop, which provides the counting ability. And I check my Bible, and it says the counter goes in X20. So I'm going to initialize X20 with 0. I know I'm going to need a label. I'll make it a temporary label. And let's see, shall I do it the way that you would normally think about writing a loop, or the way that a compiler would generate the code to write this loop? For clarity, I think I'll do it the way you think about it, which would mean that here comes the comparison of x20 to our stop value, which is 100. Now, let's see. I know I'm going to need a branch to the very end, and what I do by convention is name my very end target as 99. Now, these are temporary labels. You're not going to run out. So if I see 99, if I type in 99, that means what do you need? I'm going to the place where you need to go before you leave the program. Okay, now what kind of branch do I want here? Let's see. Now this is going to be 100, it's going to be what's ever in x20 minus 100 produces the status bits. So let's say 0 minus 100 is a negative number, be negative 100. So what I want is branch greater than or equal to, so I'll stop at 100 to 99 forward. And then I need at some point to increment. I'll just come up with a random, almost random um, label here, call it 80. And this is where you're going to go if you need, at the end of the loop. This is the post step of a for loop. So I'm going to add to x20, I'm going to add, whoops, see, there would be a bug. I'm going to add to x20, I'm going to add the value of 1, and then I'm going to branch back to 1 backwards. And at this point, I should test my program. And it shouldn't produce any output, neither, oops, see, I got a problem there. Line 26. Operand 2 must be an integer. Oh yeah, look, I made a mistake in my syntax. I want to add x20 to 1 and put the results in x20. All right, so here I'm going to build. I'm going to run it, and it produced nothing. That's the correct answer. If I want to be more thorough in my test, here's what I can do. I can load up. I already have this template down here for printf. I can load that up into x0 because it's a pointer, fmt, and I can put the value that I want to print in W1. No, wait. Let's see. Yeah, I need to make this, I need to make a change here. I'm counting in x20, so that's a long. Now printf, to be perfectly correct, I need to print a long integer. So LD. That makes that right. Otherwise, I could have changed it to W20 and used the D. So let's see, where was I? All right, I loaded up the address of the format string, and I'm going to put into x1, x20. I'm going to call, thank you, I'm going to call printf, and then I drop down into the next part of the loop. So what should this do? This should print out the numbers 0 through 99, each on a line by themselves. Let's see if that works. And there you go. Okay, so it started at 0 and went up to 99. Good, so that way I've tested, I know that this direction, branch greater than or equal to is the right branch to have done. Okay. I'm going to need this. I'm going to actually need this later, so I don't know when I'm going to need it. So I'll just comment it out and recycle it later. Okay. So let's look at our spec. Divisible by 3, divisible by 5. That sounds like the mod operator. Unfortunately, the ARM 64-bit architecture does not have a mod instruction. So instead, what we're going to do is create our own function to do that. So let's go here. It'll be mod is the label, and the first thing it's going to write is a way to return. Let me make some documentation for it so I know what I'm doing. Whoops, that's going to be a hard habit to break. Okay, and mod AB implements A mod B. The way it's going to work is integer divide A by B. For example, you're going to do 5 mod 3 would need 5 integer divide. We'll use the Python syntax to make sure you know it's a integer divide, 3, and that would be yielding 1. Okay, then I'm going to multiply result by B. That would give 1 times 3 is 3, and then subtract the result from A. So that would be 5 minus 3 yielding 2, and that's our return value. Okay, now we could do this in specific and individual instructions. It turns out there's one instruction that does both of those lines, if we could only figure out which register is which. So let's try it and see what happens. I'll do a test, and if the test works, I'm done. Okay, so how are we going to do this? So first I want to do an integer divide. Div, thank you. Divide, so where is A? A is in, what am I doing here? Am I using, yeah, I'm using X values because longs, all right. So I'm going to divide, putting the result, I'm going to need A again. So putting the result into x2, I'm going to divide x0 by x1. So that's a division of A divided by B, the result going into x2. And I can even make a notation for that. X2 gets A divided by B. And then I'm going to do this fancy instruction, which is M sub. No, I don't think that's the right instruction. Let me do a quick check. Okay. So coming back here, I have looked up how to use M sub. And I'm going to put the results of the M sub in x0, and I'm going to take that integer division result here, and x0 and x1. and x1 and x0 maybe. How's that? Okay, so x0 gets let's see, a divided by b times, that was an integer division. I'll make that more definitive, times, let's see, times b. And all of that is going to be subtracted from a. And the result going into x0 means that's where I put the answer. So, hey, let me test that. So I'm going to do a test of looking at the remainders or the mods of 3. So I'm going to put the counter into x0. That's where a needs to be. And that's coming from x20. And I'm going to put 3 there. I'm going to call my mod function. And then, hey, see, I told you I'd need this again. I'm going to print the result, but I need to fix this a little bit by copying the result to x1 because that's where printf is going to want it. So let me save and try to build. Okay, so instead of div, we'll make that perhaps a, do we really care? Make that assigned to div. And let's run it, see what happens. And there you go, I did it correctly. 0, 1, 2, 0, 1, 2, 0, 1, 2. Just for grins, I'll do mod 5. And you'll see the result. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, so mod is now written correctly. And let's see, so over here, we want to test for divisible by 3. But you know what? We've got to set our Boolean. So our Boolean is going to be in W21. Every time through the loop, we have to set the Boolean to false. So move W21 gets the value of the 0 register. Okay, now test for divisible by 3. So put the counter in x0, put the 3 there. And so if the value is divisible by 3, that means the return value of mod, which is in x0, will be a 0. If it's not a 0, it's not divisible by 3. So compare branch not 0, x0, to the label 2 forward. Okay, so if we get here, the counter was divisible by 3. All right, so what do we do when the counter is divisible by 3? We load up into x0 the fizz, and then we call printf. Okay, then we make sure that we set our Boolean, and that's the Boolean is in W21. Make sure that the Boolean is changed from false to true. Okay, all right. And here's where we test against 5. So that would be the label 2. You know, it would be fun. Let's change this temporary label to 5 so it lines up with that we're testing against 5. No other reason than that. Okay, so move once again x0 from x20. So x0 gets the value of x20. It's unfortunate that it's called a move. It really ought to be called a copy, but it is what it is. And x1 will get 5. Branch with the link register, in other words, call a function. Let's call mod. Compare and branch not 0 to, let's say, 10 forward. And if we get here, the counter was divisible by 5. So therefore, load up into x0 the address of buzz and call printf. Okay, so we got to make sure that we set our Boolean, and that would be add. It could also be a move of a 1. It really doesn't matter what the value of W21 is, apart from either it being 0 for false or anything other than 0 for true. So W21, 21, 1. Okay. Here's where we go. After testing for the individual numbers. So now we have to interrogate the Boolean, and if the Boolean is true, it means we've printed something. So I'm going to test it for false, you'll see. So compare and branch 0, thank you, of W21. So if it is 0, that means it's false, which means I haven't printed anything. So I'll go to 20 forward. And so if we get here, it means that we have printed something. So either fizz or buzz or FizzBuzz. So all we need now is a new line, because neither of those printed a new line. Okay, so load into x0 the address of the new line, and oh, you know what? Let's see. I need one more template, or I can cheat. Let's try cheating. Let's change the contents of the new line to a null terminated empty string. And let's see. So here, instead of calling printf, I'm going to call puts, because puts prints a new line. This is to be commented out. And let's do a test. So notice that if I haven't defined a 20 yet, so let's just put in an empty 20. And so if I print the either fizz or buzz or FizzBuzz, it'll finally get here, which means it's going to fall through to the bottom of the loop, and that means I can perform a test. And let's see, and do it. And I got the same result, and that's unexpected. So I look up and I notice there's still the dot here. I haven't saved the code. So let's try that again. All right. And, oop, I forgot a field on line 51. Okay, so I should be testing x0. Okay, do that again. And let's see if the pattern is correct. So 0 would be a FizzBuzz. Then 1 and 2, the code hasn't been written yet. Then 3 would be a fizz. And then 4, the code hasn't been written yet. 5 would be a buzz. So I'm thinking this looks pretty good. So what I need now is, actually, I'll be completing the program. Let's see. So from here, I need to unconditionally branch to 80 because I've done everything I need to do. So now I can start handling this case. If we get here, the counter was neither a multiple of 3 nor of 5. Therefore, we need to print the counter itself. All right, that's going to be really straightforward. We actually need that. And darn it, I did those Mac keyboard shortcuts. So there's the format in x0, and then we need a copy of the counter in x1, and that is from x20. We call printf and then fall through to the bottom of the loop. So let's try this now. Build it and run it, and I made a boo-boo. I wonder what boo-boo I made. So let's see, the branch to 80, that's good. Let's see, format. So LDR, the address of format, it's an ASCII Z. Put that in X0. Copy X20 to X1. Branch for the link register for printf. I wonder what our problem is. So here's what you do. Here's what we're going to do. I'm going to rebuild with the debugging option. And now I'm going to run the debugger. That would be running it on a.out. Let's see. Good. Now the thing I wanted to see is to make sure is reading symbols from a.out. So that confirms that when I run this, I'll have access to the source code. So just run it, and it should crash. There's my crash. And let me see where I crashed. I'm somewhere in nowhere land. So I crashed somewhere in printf. What is our backtrace? I want to find out where it is that we left my code. Let's see. So I've corrupted my stack. And how did I do that? Let me make sure it's otherwise not associated with my program. And so go ahead and run it. Oh, isn't that interesting? So it's not associated with that part. What did I do wrong elsewhere? Huh. Now it printed a FizzBuzz. That's for 0. So tell you what, let's actually debug this and see where it's going bad. I've built it for debugging, so let me launch GDB with it and put a breakpoint at main and run it. Okay, so next, and this should not take the branch. Good. I'm putting the 0 into the Boolean. There, print x0. Okay, it's divisible. So I should not take this branch, and I didn't. So loading up x0 with fizz, calling printf. Now nothing will print out because there's been no new line yet. Printf is a buffered printing. So set the Boolean to true. And now notice we're on the testing for the value 5. Call mod, and that should also be true. I mean a 0, sorry. That's correct. And load up buzz. Make the Boolean true. And compare, notice we've gone down to, we've reached 10, label 10. Compare the Boolean to 0, and the Boolean should be, I guess, 2, W21, it is 2, and then load up the new line, call puts, branch to the bottom of the loop. Oh, there's my bug right there. Look, I went into La La Land, and it was right after that branch. Notice what's missing, the F. So instead of branching to my label, I branched to address 80, which is like really, really unfortunate. Okay, so I see my bug. And we'll branch to 80F. Okay, save that. And let's build it again. And run it again. And somehow I didn't get my numbers out. All right, so I've moved on. Oh yeah, look at that. I commented out the printf. All right, let's put that back in. So you see, I'm going through my normal process here, and I'm making mistakes just like you'll make mistakes. And I've also walked you through the debugging process. Let's build it and run it. And I go out to a bar, and no, I don't do that because 1810, you're usually freshman, so you don't go out. You do not go to a bar, seriously. But I do celebrate. I celebrate by having a ginger ale. So 0, 1, 2, fizz. So FizzBuzz, 1, 2, fizz. That's 3, 4, 5, 6 is a fizz again. 8, 7, 8, 9 is a fizz. 10 is a buzz, and then 15 should be a FizzBuzz. Okay, I am satisfied. 90 is a FizzBuzz. Good. And let's see the return value of the program. It's 0. So the next thing I'm going to do is put my name on it. Wait a minute. I just said 1810. You're not in 1810. You're in 3510. Wrong 10 course. So who knows? Maybe you do go to a bar. I have no idea. Let's see. So I put my name, and you don't put my name. You put your name, just to be clear. CSC 3510, and I save it, and I turn this puppy in. Okay, here we are.